Good morning, good afternoon, and good evening. Welcome to the Crazy Hat Chemist yet for another video here. Today we are doing the Stoichiometry 101 worksheet number 3. Let's highlight that here right at the top here, folks. That's right, Stoichiometry 101 worksheet number 3. That's right. All right, fantastic. So we're going to get started with this one here. Before we get started, make sure that you watch Stoichiometry 101 worksheet number 1 and 2 prior to doing this, as well as watching the stoichiometry flowchart worksheet, as well as one more video, and that is how to determine the molar mass of a compound worksheet number 2. You need to be watching all those videos prior to watching this one. This is kind of the culmination of all of that. Okay, fantastic. Here we go. So let's get started and let's get moving here. All right, so one of the first things that we're going to do is look at the question, figure out what we're asked to solve for. It says determine the molecule. So I'm going to highlight that. We're going to keep that in mind. We're going to determine the number of molecules. And then the next thing that we're going to do is we're going to figure out what we have, and then what we want to get to. We always want to get to something, and we always have something, and that's kind of the deal here. So what we have and what we want to get to. And remember this, NUF. What does that stand for? Number, units, and formula. Number, units, formula. So that's going to be critical here. And the number that we have in this problem is 0.12. The units that we have in this problem is G for grams. And then the formula is H2O. So we're going to keep with those things right there. What do? You always start off with a number, units, and a formula. That is going to be critical. So here we go. Number 0.12, the units, grams, and the formula H2O. Fantastic. What I'm going to do is I'm going to use a ruler to help negotiate this here. We have a vertical stop between this and the next term, and then I'm going to use a ruler just to make everything nice and simple and straightforward for all of you out there in TV land, if you will. All right, so one of the key features here of doing this is what we're going to do is we're going to look at our flow chart. Well, I have grams and I want molecules. So we're going to have to look at this flow chart. I'm going to fold it here just a little bit so that certain things make more sense than others. So this is the flow chart, but we're going to look at a certain section of this. What section are we going to look at? Well, we have a mass that is right here, and we want to get to molecules. That's right over there. There is no direct single step that goes from mass to molecules, like there's no airplane flight that goes there. We do have to go to that intermediate step of moles. So we're going to go from mass to moles, and then from moles to molecules. I do have some other writing on here, as you notice, and some highlighting, and that does correspond to the previous video that's on this stoichiometry flow chart. So please, again, watch that. All right, so we're going to go from mass to moles and then to molecules. So this is going to be a two-step problem here. All right, so let's slide this on over. And again, one of the major features of doing this whole process here is dimensional analysis, stoichiometry, unit conversion method is looking at the units and formula of which I have in the numerator. I'm going to have those same units and formula, that's grams of H2O, in the denominator of the next term. These two things must be the same. It's kind of like I'm going to take a picture of the grams of H2O and I'm going to send it to a friend, and that friend is right here in the denominator of the next term. So from grams, what can I go to? Well, I need my flow chart for that one. From grams, which is a mass, what can I go to? I can go to moles. So that tells me what the units are in the numerator, and that would be moles. What is the formula? Well, that's not going to change because I have grams to moles. That's the same formula. All right, now that I have the units in the numerator and denominator, that's units in the numerator, moles, grams in the denominator, Now what I need to do is place the numbers that belong there. And that comes back to the flow chart, folks. That's correct. That comes back to the flow chart. And the flow chart says that going from mass to moles or from moles to mass, I'm going to be using the molar mass. All right. And what is the number in front of the mole? That is a 1. So I'm going to place a singular 1 right there in front of that. Now I need to determine the molar mass for water. And we have actually done that previously on a previous video, but we're going to do that just right now, just in case. So hydrogen has a molar mass of 1.01 and oxygen has a molar mass of 16.00. So I'm going to be taking advantage of both of those. I'm going to do this off to the side on this problem here. So 1.01 for hydrogen, there are two of them. 16.00 for oxygen, there's one of them. I'm going to multiply and then add these two numbers up. 1.01 times 2 and 16.00 times 1, and then add them up, and I'm going to get 18.02. I'm going to round that number to the fewest number of decimal places, which is 1, 2, 1, 2. This will have 1, 2. So this is the molar mass of water. That's 18.02 using the periodic table that I have. Now, the next thing that we're going to do before we move on to any other step, we're going to make sure that our units and formula cancels out from the numerator to the denominator of the sequential terms. Perfect. Now, in a previous video, stoichiometry worksheet number 1 and 2, this might have been the end because all of those videos had a one-step process. This video has a two-step process on each one of these calculations. So this is really pushing it over to the next level. I'm going to have a vertical stop here. And how do I know? Well, I have moles and I want molecules. So I'm going to actually continue this process here. I'm going to extend this line out further because that's what we need to do. Now, whatever is in the numerator of this term, and I'm going to use a different color this time. So whatever is in the numerator of this term, I'm going to have those same units and formula in the denominator of the next term. So it says moles of water in the numerator. I'm going to have moles of water in the denominator of the next term. And so now what we need to do to figure out the units in the numerator, we're going to pull out our flow chart. And our flow chart says that, well, we have gone from mass to moles. That's what we have done with this one singular step here using this unit conversion. I'm going to go from moles to molecules. That tells me that molecules needs to go in the numerator of this term because I can go from moles to molecules. The formula is still the same. That's not going to be changing. Okay, and then what are the numbers that are associated with these units? What's the number in front of the mole? It's absolutely a 1, that singular 1, just like it was before. It's not changing. Then what is the number in front of the molecule? It's right here. It is called Avogadro's number. It is 6.022 times 10 to the 23rd. 6.022 times 10 to the 23rd. All right, that's what we've got. So now what we're going to do is we're going to cancel out our units and formula from the numerator to denominator of sequential terms. And now what we can do is actually plug this into our calculator. You should see that I'm ending with molecules of H2O. What did I want? Determine the number of molecules. So that's what I'm actually solving for. So we're going to pull out our calculator. We're going to clear it, make sure the memory is cleared, and we're going to keep on doing this and plugging this into our calculator. Okay, now a quick little note here. We do not have to multiply or divide by ones. You get the same number back. So I'm going to skip those parts. Hopefully that makes sense to you. Okay, so I really can ignore these ones in the calculator because a number times 1 is the same number that you had. A number divided by 1 is the same number that you had. So I'm going to ignore the ones. If the number is in the numerator, I'm going to multiply. If the number is in the denominator, I'm going to divide. It's that simple. So I'm going to take 0.12, divide by 18.02, times 16.022 times 10 to the 23rd. All right, so let's give that a try in our calculator right here. Let's see if you can maybe see some of this. Here we go. 0.12 divided by 18.02 times 6.022 times 10 to the 23rd. Now you notice something here that I have an E here, and you should watch some of my previous videos to understand exponential notation, how to actually plug it into the calculator. Okay, and then so this is the number that I'm getting in my calculator right here. And hopefully you're getting the same number. You should be doing this with your calculator as well. And so that you can verify what I'm getting on mine. So what I'm going to do is I'm going to write this number down up here. It's not completely rounded. 4.01021087 times 10 to the 21. You cannot forget about that exponent. Now, what we need to do is look at the number of significant figures we have in this problem. Leading zeros do not count, so I'm going to cross that out. Okay, but that 1 and that 2, those are non-zero integers, they count. So this number has 2 significant figures. This number has a captive 0 that counts, that has 4 significant figures. This is a definition, so this has an infinite number of significant figures. This is a definition, infinite number of significant figures. That is, 1 mole is equal to the molar mass, and this is a measured value on the periodic table. 1 mole is equal to Avogadro's number, and I have it with 4 significant figures. It can be more, but it just has 4 for us. Then, so that's 2 significant figures. It's the least number of significant figures. That's what we're going to use. So I'm going to underline 1 and 2. I'm going to round with that 1. That is less than 5. I'm going to chop the number. Now, make sure that you still include this times 10 to the 21. That's very important. So it's going to be 4.0 times 10 to the 21. And then the units that did not cancel out are molecules, M-O-L-E-C. And then the formula is H2O. Just like that, I'm going to circle my answer to let everybody know that is my answer. Perfect. Now, what we're going to do is we're going to do the next problem here. The next problem says determine the mass in grams. And what do we have? Well, we got to find out where that number is. Here's the number here. It's 2.3 times 10 to the 21. That is the number. The units are molecules, and the formula is magnesium fluoride, which is MgF2. So I'm going to write down what we have. That's number, units, and formula. So I have 2.3 times 10 to the 21. That's molecules of magnesium fluoride. And I'm going to do the same thing that I've been doing all along. That is a vertical stop between this and the next term. I'm going to pull out my beautiful ruler. Now, you don't have to use a ruler. I just like using a ruler so that it is clear for all of you out there. All right, perfect. Now, what we're going to do is whatever the units and formula are in the numerator, I'm going to have those same units and the same formula in the denominator of the next term. And so everything is still the same as what we've been doing before. We got molecules of MgF2, molecules of MgF2. That's perfect. I'm going to slide this up so that I get some more space here to put down what we need. Okay, so what do we need? We need our flow chart right now. That's what we need. We need the stoichiometry flow chart. All right, and we have molecules, so we're here, and what do we want? We want mass in grams, so we need to go all the way here. Is there a direct route from molecules to mass? No, there is no direct route, in fact. So I actually have to go from molecules to moles, and then from moles to mass. This is kind of like a map here, and it allows me to travel from molecules to moles, and then from moles to mass. This tells me what the units need to be in the numerator. From molecules to moles, moles is in the numerator. Same formula, MgF2. And then we need to figure out what the numbers are. The numbers are written right here for us. What's the number in front of the mole? Let's do the simple one. It's a big fat singular 1. What's the number in front of the molecules? When converting from molecules to moles, it's Avogadro's number, 6.022 times 10 to the 23rd. 6.022 times 10 to the 23rd. Excellent. You guys are doing a fantastic job. Now you realize when you do this, you're going to cancel out the molecules of MgF2. That's perfect. And then what we're going to do is do a vertical stop between this and the next term. Let's pull this away so it's a little bit less crowded. You're doing a great job so far, so let's keep on going. So we do not have mass in the numerator, so that means we need to keep going. So these units here are moles, therefore moles must be in the denominator of the next term. Same formula, MgF2. And let's just extend that line just a little bit further. What do we want? We want a mass in grams. So can we go from moles to grams? Let's find out. Let's pull out our flow chart. Can we go from moles to mass in grams? That is correct. So this is going to be grams and the same formula, MgF2. And then what is the number in front of the mole? It's a singular one. That's right. And what is the conversion from moles to mass? From moles to mass, what is the conversion? Molar mass. So now I need to calculate the molar mass of magnesium fluoride. So what you're going to do is you're going to pull out your periodic table. There is one magnesium, that's 24.31, 24.31, and then are two fluorides, and that's 19.00. So two of these and one of these. I'm going to add those up and I'm going to get my molar mass of the compound magnesium fluoride. So that's 24.31, 19.00 times 2. And I'm going to add them up and I'm going to get 62.31. I need to round that to the fewest number of decimal places that were in my previous answers here of these elements. And that's 2. So that's 2. 62.31 is the molar mass for magnesium fluoride. You should see that the moles of magnesium fluoride here in the numerator cancel out with the moles of magnesium fluoride in the denominator. And I'm going to do that with this red pen here. We like crossing things out with that red pen. All right. Fantastic. We're looking good so far. We're going to slide this up a little bit more here. Just inching it up the path. Keeping this crazy. Keeping this crazy. All right, so what we're going to do is we're going to key this into our calculator. We got 2.3 times 10 to the 21 divided by 6.022 times 10 to the 23rd times 62.31. So we're going to put this all on our calculator here. So it is 2.3 and times 10 to the 21. How do I get that on this particular calculator? I'm going to use this yellow second button and then this button right here, which is the reciprocal, but I'm looking for that yellow EE. So right here and right there, that's actually 2.3 times 10 to the, and the power is 21, the exponent. Then I have Avogadro's number that's in the denominator. So I'm going to hit divide. That's why you see that / 6.022 and then times 10 to the is this and that right there. 23rd is the exponent and then it is times 62.31, 62.31. I'm going to get a number for this. This is in my calculator right there. I'm going to actually write that number down in blue up above, 0.237982398. Okay, and now what we need to do is we need to round this number. Before I do that, I'm just going to verify on another calculator that this is the correct answer. And 62.31. And yes, that is correct. All right. So we have number of significant figures. This is 2 significant figures. This is an infinite number of significant figures, 4 significant figures, infinite number of significant figures, and 4 significant figures. So the least number of significant figures I have is 2. Leading zeros don't count. That's 1 and 2. I'm rounding with that 7. That 7 is 5 or greater. I'm going to add 1 to the previous digit. So that's going to be 0.24. The units are grams that don't cancel out. The formula is MgF2. And I'm going to circle that because that is my correct answer. All right. That's fantastic. You guys are doing a fantastic job. We're going to slide this up and we're going to do the next problem here. Now, the next problem here is determine the molecules. So I'm going to highlight that, determine the molecules. I'm going to put this right over here so that we're just keeping it crazy, baby, keeping it crazy. All right, determine the number of molecules in what's the number 0.35. The units are grams, and it is copper 1 oxide, that's Cu2O. Again, what we do is we always start off with the number, units, and formula that are given in the problem. That's 0.35 grams of Cu2O. Vertical stop between this and the next term, and we're going to have that line continue right here, that horizontal line continue. Let's see if I need to add any more to that. Now, just like what we've been always doing here, whatever is in the numerator for units and formula, that's going to go in the denominator for units and formula. So that's grams of Cu2O, and then I'm going to have a vertical stop. That is grams. What can I go to from grams? Well, I need my flow chart out. Here's my flow chart. From grams, which is mass, I can go to moles. So that tells me what the units are in the numerator. The formula does not change. That's Cu2O. What is the number in front of the mole? That is a 1, a singular 1. What is the conversion between mass and moles? It's called the molar mass. So I need to find and look up copper on my periodic table. That's 63.55. And there are 2 coppers in this formula. I'm going to find oxygen, 16.00. And there's 1 of those. I'm going to add this up. So it's 63.55 times 2, and then add in 1 oxygen. So that's going to be 143.1. Now that's what I get in my calculator, but this has 2 decimal places for copper, 2 decimal places for oxygen. So I'm going to have to add another decimal place, and that's a 0. You have to have the same fewest number of decimal places. So I got 143.10. I'm hoping that you do understand where I'm getting these molar masses from. I didn't do it on this one or the last one, but there's copper at 63.55. We've used oxygen many times. You probably really need to be looking at my how to determine the molar mass of a compound worksheet number 2. Okay. All right, so units and formula from the numerator to denominator, they cancel out just like that. That's what we're doing. All right, have we answered the molecules? No, we have moles, so therefore we're going to continue on. So whatever are the units and formula in this numerator term, they need to be the same units. That's moles of and Cu2O. So these 2 things are going to be consistent. That will enable me to cancel them out. So I'm going to pull out my flow chart, and I am now at moles, because that's moles. What do I want to go to? Molecules. So I'm going to go from moles to molecules. What's the number in front of the mole? It's a singular 1. And then the units in the numerator are molecules. Same formula, Cu2O. And then what's the number in front of the molecule? Well, I already got the number in front of the mole, so it must be Avogadro's number, 6.022 times 10 to the 23rd. 6.022 times 10 to the 23rd. Fantastic. This will enable me to cancel out the moles of copper 1 oxide. And then what we're going to do is key this into our calculator here. So remember, numerator times numerator divided by denominator, skip the 1. So it's 0.35 divided by 143.10 times 6.022 times 10 to the 23rd. And I'm going to get this number in my calculator right here, and that is 1.47288. 6094 times 10 to the 21. Just going to verify that on another calculator to make sure I didn't key in something incorrectly. Perfect. Perfecto. I'm looking good here. That's right. Okay, so now we're going to look at significant figures here. This has leading zeros don't count, two significant figures, infinite number of significant figures because it's a definition, five significant figures, infinite number of significant figures because it's a definition, four significant figures. So the fewest number of significant figures with a multiplication problem here is two. Multiplication and or division. So I'm looking at one, two significant figures. I'm looking at that 7 for rounding. So I'm going to have adding 1 to the preceding digit. That's going to be 1.5. Don't forget about this part of that number. That's times 10 to the 21. That lets you know it's really big. The units that didn't cancel out are molecules, MOLEC, and then the formula, CU2O. I'm going to circle that. Remember, number, units, formula, that number is going to be rounded correctly, and then units and formula. You should see that actually problem number 1 and 3 are very similar in nature. They are following the same process, same path. All right, looking good. Now it's time to do number 4. Number 4, it says determine the mass in grams. And then what do we have here? What do we have? Well, we have a number, and that number is 1.8 times 10 to the 22. The units are molecules. The formula is aluminum nitrate, and that is that formula, Al parentheses NO3 parentheses and a 3. So let's get moving on this one. We're going to start off with a number that's 1.8 times 10 to the 22 molecules of aluminum nitrate. Vertical stop between this and the next set, and we're going to draw that horizontal line. Perfect. Excellent. Continue on. So, since these units here and formula are written down here, that means I need to write those same units, molecules, and the same formula, AlNO3 parentheses and a 3. Vertical stop. So I have molecules, I want grams. So I'm going to be pulling out my flow chart for this one most certainly. Absolutely. And that's what we're doing on every single one of these. Not like this is any different than the rest. So I'm going to slide this up just so that you can see that chart at the same time as the problem. Here we go. So I have molecules. I am here. What do I want? Mass. There is no direct flight, no direct path from molecules to mole mass. Therefore, I'm going to go from molecules to moles. That tells me what goes in the numerator. And the same formula, aluminum nitrate. What's the number in front of the mole? It's a 1. That's right, that singular 1. What's the number in front of the molecule? Avogadro's number, 6.022 times 10 to the 23rd. Perfecto. You should see that the units and formula from the numerator to denominator, they are going to cancel out like thus. Beautiful. Looking great. All right, now I have moles in the numerator up over here, as you can see. So moles of aluminum nitrate right there. Therefore, I'm going to have moles of aluminum nitrate in the denominator of the next term. I'm going to continue this vertical line. There we go. Now, ultimately, I want to determine the mass in grams. I have moles. So flowchart time, folks. I have moles. I want to determine the mass in grams. What do I use? The molar mass. So I'm going to have grams and then the same formula, AlNO3 parentheses and a 3. Okay. All right. Looking good. Now, what's the number in front of the mole? It's a 1. What's the number in front of the mass? It's called the molar mass. So I need to calculate the molar mass for aluminum nitrate. So again, you're going to pull out your periodic table. I'm going to do this off to the side like I've been doing. Aluminum is 26.98. 26.98. There's 1 aluminum in this formula. Then nitrogen is 14.01, 14.01. And how many nitrogens are there in this formula? Well, you need to distribute this 3 over both terms. So there's 3 nitrogens. Oxygen is 16.00. And how many oxygens are there in this formula? That's 3 times 3, that's 9. Okay, so we're going to get the molar mass here for aluminum nitrate. That's 26.98. 14.01. I'm going to multiply that by 3, and then 16.00, multiply that by 9. Add it all up, and I get 213.01. So 213.01 is my molar mass for aluminum nitrate. Again, the moles of aluminum nitrate are in this numerator term. That's why they're in this denominator term. And that is why we are doing this whole dimensional analysis so that we can cancel out units from the numerator to the denominator. Excellent. I'm going to key this into my calculator here, and it is going to be 1.8 times 10 to the 22. That's this number right here, divided by 6.022 times 10 to the 23rd. That's this number here, times the molar mass, which is 213.01. And I am going to get this number here. I'm going to write it up here just a little bit. So it's 6.36695. There are more numbers here beyond this, but I am only needing a certain number. It says 2 significant figures, an infinite number of significant figures, 4 significant figures, 5 significant figures, and an infinite number of significant figures. So how many significant figures do I need? The fewest number in a multiplication division problem. 1, 2 significant figures. I'm looking at that 6 for rounding. That 6 is 5 or greater. I'm going to add 1 to the preceding digit. So this will become 6.4. And then the units are grams. And the formula is aluminum nitrate. And you can't see all that, so I'm going to zoom on out just slightly. So hopefully we can slide this over and you can see all parts to that number, units, and formula. There we go. I'm going to slide this down just a little bit because I had slid it up before, and I want you to see the similarities between problems number 1 and 3 and the similarity between 2 and 4. They are following similar processes, similar paths, of course, different numbers, different formulas, and that changes the whole game. All right. You're doing a fantastic job. We are halfway through. We've done 4 problems. Now we're going to continue on with the remaining 4 problems. That's 5 through 9. Well, actually, 1, 2, 3, 4, 5. We have actually 5 more problems to do. So what we're going to do is we're going to slide this whole thing on up. Hopefully you've gathered that along the way, and we're going to continue here. So this next problem, it says, determine the number of molecules. So I'm going to highlight that right there. And then what do I have? What do I have? It says here's a number, 0.94. There's my number. My units are grams, and it is iron 3 oxide. And there's my formula, Fe2O3. So again, like as always, I'm going to start off with the number, units, and formula, 0.94 grams of Fe2O3, vertical stop, and then a horizontal section here to go to molecules eventually. Okay, let's see if we need to add on more to that horizontal. We're going to find iron on our periodic table to get the molar mass for iron, and that's 55.85, 55.85. There are 2 irons in this formula, 16.00 for oxygen, and there are 3 oxygens here. Recall that whatever is in the numerator for units and formula must be in the denominator of the next term, so that's grams of Fe2O3. Vertical stop, that has grams of Fe2O3. So 55.85 times 2 and 16 times 3, and we're going to add that up. And then what we're going to do is we're going to look at our flow chart right over here. I am going from mass to molecules. So mass to molecules, I'm going to go from mass to moles first. This tells me what goes in the numerator, which is moles. And then the same formula, Fe2O3, the numbers of which are the molar mass for the grams and the 1 in front of the mole. Perfecto. Pull this away. We just calculated the molar mass for iron 3 oxide. That's 159.7. And then there are two decimals, so I'm going to have to add that zero. So 159.70. Looking good, folks. We're going to keep on going. Whatever the units and formula are in this numerator term, they must be in the denominator term of the next term. So that's moles of Fe2O3. That will be the same right there. All right. Then from moles, what do I want to go to? Well, let's read the question. It says determine molecules. So from moles, I'm going to go to molecules. So that's why molecules is up here in the numerator, Fe2O3. All right. And then we need to figure out what the numbers are. So that's why we still have out our flow chart. What's the number in front of the mole? It's a 1. So I'm going to put a 1 right there. What's the number in front of the molecules when going from moles to molecules? It's Avogadro's number. That's 6.022 times 10 to the 23rd. You should see that as I've done this, I can cancel out grams of ferric oxide from numerator to denominator, as well as moles of ferric oxide and moles of ferric oxide. The only units that don't cancel out are the molecules of ferric oxide. This has 2 significant figures, an infinite number of significant figures, 5 significant figures, 4 significant figures, and an infinite number of significant figures. I'm going to key this into my calculator here and get a numeric value. That's going to be 0.94 divided by 159.70 times 6.022 times 10 to the 23rd. And I'm going to get 3.54457 times 10 to the 21. There are more numbers here, but I don't need to really know them. I'm going to round this to 2 significant figures. That's 1, 2, that's 4 that I'm looking to round at, and that's 3.5 times 10 to the 21 molecules of Fe2O3. Excellent. You guys are doing a fantastic job. You should see that this problem is determining the number of molecules, and it's very similar to 1 and 3. So if you've been following along, this is similar to 1 and 3. That's why I'm moving a little bit faster, because you guys are doing a great job. The next one, it says determine the mass in grams. And what do I have? I have 7.1 times 10 to the 21. I have molecules of lithium carbonate. That's Li2CO3. Start off with a number, 7.1 times 10 to the 21, the units, molecules of lithium carbonate. Vertical stop and a horizontal line between this and the next set of terms here to keep all our ducks in a row. Whatever are the units and formula in this numerator, they are going to go in the denominator of the next term. So that's molecules of lithium carbonate. Vertical stop and highlight that. From molecules, what can I go to? Well, that's why I need my flow chart. So I'm going to flip this on up here just a little bit here. So here we go. From molecules, what can I go to? Moles, especially if I want to end up with mass, which is grams. So I'm going to go from molecules to moles. So that means moles is up here. Lithium carbonate, same formula, Li2CO3. What's the number in front of the mole? That's right, folks. It's a 1. Singular 1. What's the number in front of the molecules? It's Avogadro's number, 6.022 times 10 to the 23rd. I think we were able to fit that in there. All right, looking good. Now, whatever the units are in this numerator term, they must be the same set of units in the denominator term. So that's moles of lithium carbonate. So units and formula are going to be the same. I want to end with a mass in grams. I'm going to go from moles to mass. So this would be grams of lithium carbonate. And what's the number in front of the mole? It's a 1. What's the number in front of the mass? It's the molar mass. And we're going to have to calculate that. I'm going to do this off to the side. Of course, you have your periodic table with you, of course. And lithium is 6.94. 6.94. There are 2 lithiums in this formula. Carbon is 12.01. 12.01. That's a parentheses. There's 1 carbon in this, and oxygen is 16.00, and that there are 3 of these. Okay, so the molar mass for lithium carbonate is 6.94 times 2, 12.01 times 1, 16.00 times 3, and I'm going to get 73.89. So that goes right here, 73.89. That has 2 decimals, the least number of decimals in all 3 of these elements. I'm going to cancel out molecules and lithium carbonate units and formula. Moles of lithium carbonate, moles of lithium carbonate. I'm going to get a numeric value in my calculator, and that is 7.1 times 10 to the 21 divided by 6.022 times 10 to the 23rd, then times 73.89. And I am going to get 0.87117070, etc. There are more numbers there, but I don't really need that. I'm going to look at significant figures. There are 2 significant figures. Infinite significant figures, 4 significant figures, 4 significant figures, infinite number of significant figures. The fewest number of significant figures, well, that would be 2. So 1, 2. Leading zeros don't count, but there are placeholders. I'm going to put it there. I'm looking at that 1 for rounding. That's less than 5. Truncate the number, so that's 0.87. The units are grams. Those are the units that did not cancel out. And then the formula is lithium carbonate. That's Li2CO3, CO3. Perfecto. Bingo. You guys are rocking. We've got 3 more problems to do. That's right. So I'm going to slide this on up here just a little bit more so that we got some more real estate to work with. All right. Excellent. Hey, by the way, we're going to do a short little advertisement break, and that is you are watching The Crazy Hat Chemist. Please like and subscribe. Send me comments. The comment section, as you know, is always out of control. This next problem, determine the mass in grams. Yep. And what do I have? We have a number, 1.5. We have units of liters. We have methane gas, CH4 at STP conditions. So we're going to start off with our number, 1.5, our units, liters, our formula, CH4. Vertical stop and a horizontal line between this and the next set of terms. We're just going to keep on going with this. We love it. All right, now what we're doing here is a little bit different than what we have been doing on the previous problems here. We're going to get mass in grams, and we have liters. So we're going to look at our flow chart here. We are going to determine the mass in grams, and what do we have? A volume, which is liters. So we're going to go from volume to moles, and then from moles to mass. So whatever these units are here in this in the numerator term and formula, I'm going to photocopy them and bring them down here, liters of CH4, vertical stop. And so now I'm looking at my flow chart to figure out what goes in the numerator term. So I'm going to go from volume in liters to moles. So this tells me moles, same formula, CH4. What's the number in front of the mole? As always, it's a 1. That's a 1. Now, it says this is at STP. That's absolutely critical. So at STP, 1 mole of any gas is equal to 22.414 liters. 22.414. Perfecto. Beautiful. That means that these liters here are going to cancel out in just a moment. All right. So now what we have here are the next set of units here. And let's say these are moles in the numerator. That's why moles needs to go in the denominator with the same formula of CH4. What do I want? That's highlighted in yellow. That's a mass in grams. So I'm going to pull out my flow chart again. I have moles. I want mass. The mass units are grams. So I'm going to have grams, same formula, CH4. What is the number in front of the mole? It's a 1. That singular, beautiful 1 that we always like. And what goes in the numerator in front of grams? That's the molar mass. So we need to calculate the molar mass for methane. Carbon is 12.01. There's one carbon in this formula of methane, and hydrogen is 1.01 times 4. There's two decimals in both of these here, so that would be 12.01 times 1 and 1.01 times 4, and I'm going to add those up, and that's going to be 16.05. That's the molar mass, 16.05 for methane. In order for this whole process to work, you should see that the liters of methane cancel out from numerator to denominator. Moles of methane cancel out from numerator to denominator. We're going to now get a number in our calculator, and it's 1.5 divided by 22.414 times 16.05. And I'm going to get this number in my calculator, 1.07411054. There are more numbers, but it doesn't really matter. How many significant figures here? 2 significant figures, infinite number of significant figures, 5 significant figures, 4 significant figures, infinite number of significant figures. If you're having trouble with the significant figures, you definitely need to watch one of my previous videos on determining significant figures. Least number of significant figures with the multiplication division problem is 2. So 1, 2, I'm running with that 7. That 7 is 5 or greater. I'm going to add 1 to the preceding digit. This will become 1.1. The units that did not cancel out are grams, and the formula is CH4. Boy, that is beautiful. I love it, folks. I'm going to slide this on up just a little bit more so that we have a little bit more real estate to work with for our next two and final problems. So here we go. Determine the volume in liters. That's what we want. What do we have? We have a number. That's 3.7. We have units. Grams. We have butane gas C4H10. It is at STP conditions, and that is critical as well. Most critical. So we're going to write down our number, units, and formula. Our number is 3.7. Our units are grams, and our formula is C4H10. Vertical stop between this and the next term, and let's draw our horizontal line there. And now, there we go. Whew, looking good, folks. Okay, what are these units here? These are grams of C4H10, so therefore grams of C4H10 need to go in the denominator of the next term. Okay, I have grams, which is a mass. I want to go to liters. So from mass, I'm going to go to moles. That tells me that the units in the numerator are going to be moles. And then I've got C4H10 right there in the numerator. And what's the number in front of the mole? That is a big fat 1. Now I'm going to calculate the molar mass of C4H10. I've got 12.01 for the carbon. There's 4 of those, and 1.01 for the hydrogen, and there's 10 of those puppies. I'm going to add those babies up. That's right. Here we go. All right, so molar mass, we're going to take 12.01. We're going to multiply that by 4. And then 1.01, we're going to multiply that by 10. And then we're going to add those up, and we're going to get 58.14. That is the molar mass for butane. So that's 58.14. Perfecto. All right, now what we're going to do is we are going to highlight this moles in the numerator and the butane C4H10. That means that moles of C4H10 are going to go in the denominator of the next term. Vertical stop for the next one. And from moles, what do I want? I want a volume in liters. Can we get from moles to volume? Oh, yes, we certainly can. It's at STP, at STP. 1 mole is equal to a volume in liters of C4H10. And what is that numeric value? That numeric value is 22.414. 22.414. Perfecto. All right, so canceling units out from numerator to denominator, numerator to denominator. We're looking at significant figures, 2 significant figures, infinite number of significant figures, 4 significant figures, 5 significant figures, and infinite number of significant figures. I'm going to type this into my calculator to get my answer. That's 3.7 divided by 58.14 multiplied by 22.414. And I'm going to get this number in my calculator. That's 1.42641. And there are more numbers, but it doesn't matter because I'm looking at 2 significant figures as 1, 2. I'm rounding with that 2. That's less than 5. Chop the number. 1.4 liters C4H10. 1.4 liters of butane. Awesome. You guys are doing a fantastic job. We have one more problem to do, and I know we can do it. It says determine the volume in liters. And what do we have? We have 0.14, and then we have grams, and we have carbon dioxide, and it is at STP. That's right. Okay, we're going to keep on going here, folks, even with a phone call. So what's the number? 0.14. What are the units? Grams. The formula, CO2. Vertical stop and a horizontal line. That's right. Hey, you guys are still alive here. We're doing the 9th problem here, and you are not falling asleep. I didn't think so. So whatever the units and formula are in this numerator, well, we have to put those same units and same formula here in the denominator of the next term. That's how we play this game, and we've been playing this game for a while. Hopefully that makes sense. We're going to pull out our flow chart here, and we're going from mass to moles, and then from moles to volume. So what goes in the numerator? Moles, moles of CO2. What is the number in front of the mole? It's the singular one, like always. And what is the number in front of the grams? That's molar mass. So we're going to calculate the molar mass for carbon dioxide. That's 12.01 times 1, 16.00 times 2, and we're going to get 12.01 times 1 and 16 times 2, and that's going to be 44.01. So 44.01 is the molar mass for carbon dioxide. Beautiful. The next thing here is that we've got what moles of carbon dioxide here in the numerator, therefore moles of carbon dioxide needs to go in the denominator. So I'm going to go from moles to what? A volume. I'm going to go from moles to a volume, and that is 1 mole, 22.414 liters. 1 mole, 22.414 liters CO2. I'm going to bring this down just a little bit more so you can see all of what we've been doing. Set this equals. We've got the moles in the numerator and denominator of sequential terms. We're going to cancel out units and formula, just like we've been doing. We're looking at significant figures. This has 2 significant figures, infinite, 4 significant figures, 5 significant figures, infinite. We're going to key this into our calculator. That's 0.14 divided by 44.01 times 22.414. And what number am I going to get? I'm going to get 0.071301679. And there are more numbers, but it doesn't matter. These leading zeros are important for placeholdership. I'm going to put those down. And then I got 2 significant figures. That's 1, 2. I'm rounding with that 3, so it's truncating the number. That's 0.071. What are the units that didn't cancel out? Those are liters. What is the formula? CO2. I'm going to circle that, and boy, that is a wrap. I hope you guys got all of that. Remember, you're watching The Crazy Hat Chemist, and it is crazy, and I'm wearing a hat. Or am I? Or am I not? Is the question. All right, I'm going to see you next time. Love you. So long. Farewell. Auf Wiedersehen. Goodbye.